Greetings, Management 431 is the class, and we are now in the fourth module. We are beginning Chapter 11, Choosing and Hiring Candidates. What we've done to this point is look at the different ways that we can assess candidates, both internal and external. We've talked about the strategy, we've talked about the support mechanisms like job analysis and forecasting and planning, and the legal issues. We've talked about sourcing and then assessing them, and now we're going to make that final decision. Who are we going to hire, and what's the best way that we can approach attracting them and encouraging them to accept the job offer that we make to them. In terms of our learning objectives, we're going to cover 5 basic things. Number 1, we're going to describe different ways of combining our candidate scores. So we're going to look at ways of thinking about who is the best candidate. Sometimes it's a straightforward, combine all the scores and see who's the highest. Sometimes we want to give greater weight to some scores over others. And so we'll spend time talking about the different ways we could do it and why we would do it based on these different ways. We want to look at the 3 different ways of making a final choice. So we'll have to figure out how to combine the data and then ultimately how to arrange the data so that we can make that final choice. And we have a number of different ways that we can do that. That's things like multiple hurdle approaches and things of that nature. We're going to discuss the factors that influence the content of a company's job offer. So we're going to think about, if we're going to make a job offer, what are the factors that we need to consider in terms of what we include and what we don't include, when it's appropriate to include some things and when it's not. We're also going to look at the different job offer strategies and decide why we would use one strategy over another. It all depends on all sorts of factors like what's going on in the job market, how easy it will be to find another candidate, things like that. Lastly, we'll look at the different kinds of fairness and explain why candidate perceptions of fairness are important. So we've already addressed some of this stuff when we talked about applicant attraction with recruiting and applicant attraction within the selection process, and we need to consider that as well once that final hiring decision is made. And remember, the more fair we can keep our system from the beginning in terms of transparency of information and a fair process, we hope that has a positive influence on the fairness of the outcome. And research shows that fair process and fair information tends to result in fair outcomes, but not 100% of the time. There are a lot of factors that may influence whether or not an outcome is fair, but it is usually closely in alignment with how fair the process and the information was that people received. So we'll see how all these issues of fairness integrate and have an impact on the final evaluation of fairness, which was the outcome fair. In terms of combining the assessment scores, there's 2 ways that we can do this. We can do this via multiple hurdles or compensatory approach. And why do we do that? Well, because depending on the type of position that we're hiring for, it may be more important for everybody to be good at all the hurdles, as opposed to a compensatory model that says it's okay if people are good in this and not good in this, because we can train them on those things that they are not good. And so high risk types of jobs, we want multiple hurdles, right? We want every hurdle has to be successful. For jobs that are lower level, and I would probably argue in Juniper hotels in your simulation, having a front desk clerk who is good at some things and can be trained on others would be perfectly fine. A front desk clerk is not going to need to be at the highest level of excellent on all aspects of the job. So consider that as you're going through the process. Ultimately, we want to make sure that we understand when we use the compensatory model and when we would use the multiple hurdles model. And we want to make sure also, based on measurement issues, that we are properly combining the data that makes sense with respect to their overall performance score. We want to make sure that we are using data that makes sense, and it can be assigned the same scale of reference. That's what we're looking for. In the multiple hurdle approach, candidates have to have a passing score on the assessment before being allowed to continue to the next step. And ideally what we're looking for is people who perform well and high on all those aspects. It is significantly more costly, right? Because you're spreading out these hurdles over time, and it can take time for people to pass. But we use this when poor performance can be a real problem. So when we have high-risk jobs, when safety is a concern, when we need people to be excellent in all areas. For example, a surgeon. The last thing you would want is a surgeon who was really good at making cuts, but not so good at doing stitches, right? I mean, we want them to be good at everything across the board. So when safety is at risk, it's really important that we have high hurdles. I would not say that the front desk clerk for Juniper Hotels is a high-risk job. I would definitely not say that the sales associate for Churn's department store would be a high-risk job. Neither of those are high-risk jobs, and therefore do not justify having a multiple hurdle approach. In terms of the compensatory approach, what we're looking for is high scores on some areas to compensate for low scores in others. And in essence, when people have to have a specific talent, like you would with the multiple hurdle approach, this is not a useful approach, because we do want people to be equally good, if equally good in all areas when things are much more stringent and when really specific talents are important. But otherwise, most people use a compensatory approach where we identify who's the best candidate overall based on their sort of compensatory model of their assessments. And then we recognize when they come in, we identify where there are training opportunities, and we make sure that they get training in the areas where they want. I went to work for a company after I left the bank, and I worked for a bank for a while, and they had me doing budget work without using an Excel spreadsheet. And that was frustrating to me. Actually, at the time, it was called Lotus 123, but it's Excel now. So since I wasn't allowed to use a spreadsheet, I really wasn't familiar with how to do a spreadsheet. So when I started the new company, they said, we want you to be using, a spreadsheet program to do the work that you need to do for this. And I said, I'm skilled in all sorts of computers, languages and formulas. I can do this, but I am not familiar with the spreadsheet program, and I would need training on this. But you can see from the breadth of programs that I know how to use that I have skill in all those areas. And they said, no problem. They hired me, they brought me in, they made sure I got trained on the two programs they wanted me to use, which was DBase, which is a database program, and also in Excel. So as I said, Lotus 123 at the time. So basically the spreadsheet program as well as the database program, they made sure I got the training I needed for both of those, which was really helpful, considering my previous employer refused to train me on that and give me access to those computers. So that being said, you have to decide really during the job analysis process whether this is something that's absolutely essential that someone has to have coming in, or whether you think that a willingness to learn and then an ability to train them quickly on this is important enough for you. And so that determination starts at your job analysis process. If everything in your job analysis is considered high and they absolutely have to have it, then you use a multiple hurdle approach. If some of them are okay and they can be trained once they enter, then that's where we recognize the compensatory approach is more important. So as you're ready to do this, you've got to determine which of those things are essential, and then which of the things are okay to be taught later, and make your decision based on that. If you're going to do multiple hurdle, it's very easy to do. If they hit the cut score, if they've passed the exam or the assessment, whatever the assessment is, they get to move to the next hurdle. But with compensatory, it's a little bit more complex because you are combining all of the assessments in one general assessment. So you've got to decide, how do you want to combine the data? Do you want to do it with unit weighting? So are you going to give multiple assessments equal weight? Are you going to do rational weighting where people have a subjective weight? I believe this is more important than this. This is worth twice as much as this, so therefore that should be worth 40 and this should be worth 20, right? Statistical weighting comes from putting things into a multiple regression equation and looking at the different weights based on the assessment. And you did that in your measurement exercise. Remember the exercise where you had to plug in the cognitive ability tests to get their real performance scores. And that was an example of using a regression formula to plug in the performance on cognitive ability tests. And of course, we only had one assessment in that exercise just for the purpose of illustrating how you would do that. But often if we have multiple assessments that we're using, we would use multiple assessments to come up with a formula that would include different weights for different assessments. And so you'd have your slope, you'd have your slope, and then you would have your score for your cognitive ability, your score for personality, or whatever other assessments you were using, and then those would be combined into a performance score. So you would be able to see what true performance would look like given a whole host of different assessments. So you can use the statistical weighting or your regression formula to do that. Multiple regression is the most scientific approach to using weighting assessments, and so being skilled and being able to do that is important. Here in table 11.1, you see the unit weighted approach, basically where everything is weighted similarly. So the structured interview is as important as the knowledge test, which is as important as the assessment center. And so you would do it, for example, Ying got an 89 on her structured interview, a 25 on her knowledge test, and a 6 on her assessment center. Now, remember, based on measurement, all of these have different scales, so you can't simply combine those scores and add them up and look at what that means. You have to calculate the standardized score for them first, and then you add up the standardized scores. Adding up your standardized scores makes sense because it gives you a sense of how much above or below the mean they are, specifically for their overall test scores, overall assessment. Tony has 60 in the structured interview, 35 in the knowledge test, and 7 on the assessment center. So he didn't do as well as Ying on the structured interview, but did significantly better on the knowledge test, and the assessment center slightly greater than the assessment test. So if you do straightforward weighting and you assume they're equally as important, then absolutely Ying would be your candidate for the job. Now, Tony would still probably be good. They didn't do as well in the structured interview, and you have to figure out why they maybe didn't do as well on the structured interview. Sometimes people they get nervous and they don't always speak well in interviews, but they clearly have the knowledge and they clearly could perform well in the assessment center. So here in this situation, they'd be weighted the same. But consider if you wanted to weight something a little bit more heavy. So let's say that the job knowledge test was weighted twice as heavy as the structured interview in the assessment center. So you would double the job knowledge score, and then you would, which would be for Tony, would be 1.7 times 2, that would be 3.4. And for Ying, it would be 1.1 times 2, which would be 2.2. And you would add them up, and you might see a totally different score in terms of who would be better for the job. So this is where unit weighting is really good, and it's really simple, assuming that everything really is equally as important. But oftentimes it's not the case. Sometimes knowledge and maybe even the assessment center score is significantly more important than how well people do on an interview. It sort of depends on the nature of the job. Other jobs may say, the interview is more important because they're going to do a lot of talking on the job. So you have to decide whether unit weighting makes sense or whether you want to, vary the weighting on the different scores in a different way. In terms of the statistical weighting approach, as we've already said, you're going to get your multiple regression formula. You get data over a whole host of different applicants. You're going to plug that data in, plug in their performance data, and you're going to get a formula that tries to predict how all those predictors influence performance, what the weighting is overall. And so obviously I don't make you hand calculate regression equations because that was a brutal thing that I had to do in grad school, and I don't think that you guys need to know how to do that. We have statistical programs that can do those calculations for you, but you need to know what your dependent variable is, which is your performance score, and then you need to know what your individual assessments are and how people scored on those individual assessments, and you need to have a sizable sample of people over time that you can take, you can plug it in, and you can do your calculation. So in this formula, C is your constant, right? That's where it crosses the y-intercept. It's your, in essence, it gets at your slope, or at least it gets at where it crosses the y-intercept. So I misspoke in the previous slide. It wasn't the y-intercept, but it was actually it wasn't the slope, it was the y-intercept. Anyway, C is your constant, and each of those B's are the weights of the assessment method. So each of them are going to be different, greater or lesser, depending on how important they are in the overall assessment. So if you look at the example in the middle where it says overall score equals 24, which means at a minimum, it crosses the y-intercept at 24. And that's sort of the lowest performance you could expect, even if someone had 0 on everything else. Cognitive ability is weighted 0.2, interviews are weighted 0.25, and personality tests are weighted 0.15. No, that doesn't add up to 100. It's okay. It doesn't need to. It's just a statistical weight. It's not a weight out of 100 like you would with the unit weighting. So it's slightly different. So the cognitive ability score of 70 and an interview score of 75 and a personality score of 50, you'll end up with an overall performance score of 64.25. So you plug in individual scores, and now once you've established that formula, you plug in the data after that, and you should be able to predict which candidate should perform the highest on the job based on historical data of performance assessments that you've used in the past. So that's how we work that one out. There are a couple things you should know about using statistical weighting, specifically when you use it with multiple regression. The most accurate way of using multiple regression is when you have several hundred hires to work off of. Right? This does not work with small samples of 50 or 60 or even 10. It might work a little bit over 100. It's okay to use it. It's not the best, but it can be used over 100. But your ideal would be over 200 for sure. You want to make sure that there's a low correlation among the selection methods, meaning that each one of them isn't really correlated with each other. They're not influencing each other, that they're very unique in their contributions to performance overall. So you want to see a low intercorrelation among the assessments that you're using. So in our previous example from the previous page, the correlation between the personality test, the job knowledge, and the cognitive ability test, we should see a low intercorrelation between those three. And we should see a relatively small number of assessment methods, right? You're not going to be doing this with 10 or 15 or 20 assessment methods. Typically 2, 3, 4, maybe 5 tops would be ideal. So you don't need to worry about doing a really sizable assessment program. So you have a couple of hundred in your sample, you have low intercorrelation among the assessment methods, and you don't have a lot of assessment methods. 3, 4, or 5 would work ideally. Other things you have to consider is, because weights can differ when derived from different groups, is to see whether or not that regression equation holds with different subgroups of employees. For example, will it work well with senior level people versus lower level people? Does it work with jobs that are mechanical versus jobs that are more office focused? Those kinds of things. And so that's part of that external validity. We want to make sure that we're clear that this will work with a particular group of employees or applicants, and it works for one versus another. If you're estimating the regression equation in a large sample is not possible, unit weighting or even a rational weighting may be the better choice. So really, if you have a small sample, you're better off using your own best judgment about what you think is more important, doing unit weighting, or as we said, the rational weighting, where you adjust the weights, in your unit weighting to not be equal, but to be slightly different. Validity can sometimes be enhanced by combining multiple regression approach with a global judgment. So you can see what your global judgment would be, and then you look at that relative to your regression results and see if combined they're both getting at the same sort of ideal. For example, if you do have a small sample, you might want to, like around 100, you could do your own sort of rational or unit weighting and then run a regression and see if there's alignment there. If there's alignment, then you might be able to get away with using your statistical weighting or your regression equation to help you with that. Sometimes it's okay to combine multiple hurdles and compensatory approaches. And that happens when job requirements are essential to job performance, and some of them are essential, but some of them, can compensate for each other. So we might have to decide which ones are the most important that need to be in the hurdle, that they absolutely have to be successful at. And then the rest of them can be combined in a compensatory approach. So you could do it. And here's some examples. A data entry hire may need to type a certain number of words per minute with a minimum number of errors, which is a minimum hurdle. And then cognitive ability and personality may be combined in a compensatory factor. So at a minimum, they have to meet the minimum requirements for the typing and the errors. And then after that, everything is compensatory. The typing test is used at the beginning to weed out the people who cannot meet that minimum hurdle. So use your hurdles first and then use your compensatory methods after that. And that's the best approach to using the two of them combined.